Testing. Good. All right. I just finished handing out the quizzes, and so now you can see the details about how your quiz was graded. And I need to take care of this first here. Network. Not that one. There we go. And today, I spent 2 lectures already going over the type of problems that are on this quiz. And so today, I don't want to spend time repeating that because I think that you can review those lectures. The recordings are there online. You can review those and also practice going through this quiz and try to get the answers correct. And you can test the answers that you come up with by writing short programs and running them to verify whether the answer that you came up with is correct or not correct. That's a very good exercise for you to do, and I recommend that. Anybody have a suggestion on how to get connected here?
Go to the school website.
Go to the school website? Oh, wait a second. Maybe I'm on the wrong network. I want this one. That's it, isn't it? I got it. I don't want to log in. Okay. All right. So here we are. Quiz 1, as you can see, it's worth 200 points. The grades, you want to talk about this for a minute. People are concerned about this. And we can look at the whole sort of grade result here together. And obviously there's a bunch of people that got A's and those, and it slide down into the F's. Now, if you got a 0, it's not the end of the course for you. You can still score a good grade in this class. Okay, if you got a 40, 50 in that area, once again, it's you have plenty of opportunities in the coming weeks to demonstrate your learning of this material and your competency in this material. So with a score of a 0 on quiz 1, it's not going to kill you. But what it is, it's kind of like a warning. So you need to change your study strategy somehow. Whatever it is, the time you spent on the course, either you're not putting enough time in there, or else there could be other factors. Maybe you're too tired because you're working or whatever. So those other factors that are also possibly there. But if you are spending time on the course and you're not getting good results, then you need to think about changing the way you approach the learning. And what I did with assignment 1 is I gave you basically a simulation quiz 1. If you did well on assignment 1 and poorly on quiz 1, that means you did not do assignment 1 correctly. You did not simulate the testing environment in which quiz 1 occurred. So you need to think about that. With these assignments, you need to treat them as testing simulations. And it's your way to practice, to prepare for the test, or for the quiz, or for the finals. I don't give surprise questions on the tests. They're different, they're unique, but they're very similar to the material I cover in the assignments and in the labs and in the lecture. So there's no major surprises. There's just little surprises that enable you, that require you to think creatively and to think computationally and to solve a computational problem. And that's what this class is all about. And I think that all of you can end up mastering that. But for those of you who are scoring well already, that's great. You got it. You got it. So you're going to probably do well for the rest of the class. Or for those of you who are not scoring well yet, you've got to think about approaching the way you study the material and the way you prepare for the exams differently. You're going to think about that. Now, if you want to talk to me privately about it, and I can give you some advice or give you feedback on how you explain the way you approach the material, I'd be happy to do that. All right. Any questions about grade or anything, difficulty levels? All right, in that case, let's go to the lab 4, which is due today. And in lab so far, in the 2 instances of lab that we've had already, I've covered exercise 1 and exercise 2, although in the 2 labs ago, I probably didn't spend a lot of time on exercise 2. But what I'd like to do is jump in and just start looking at how to solve exercise 3. Let's talk about this.
Good question.
Yeah.
When is this one due today?
This is due tonight. Yeah. So midnight tonight should get this done. You don't have to go to lab to get it done. You can work at home. Or you can work anywhere on campus, but you need to, of course, log in to the lab machines.
That's another question too. Over the weekend, like as far as SSH,
Yeah.
because for some reason, like it's disconnected, and like you can try for like 2 days. And if I can't SSH into
You still can't get in?
Yeah, it's random. Like
You can get into JDHG, but you can't get into
and it starts on like Friday at midnight.
Try 358 too.
I
But
tried
yeah,
it.
you know what? That's a problem. Yeah.
And then like the whole weekend you go and you can't.
Yeah. So you're out of luck there. I mean, the best thing to do. So that's that's a problem that we're just not providing that service well. So. Yeah, if that's been a problem for you, you can send me an email and ask for a day extension or something like that. So I'll handle that on an individual level. But that's a valid complaint. I appreciate that. Another way to approach this is to get a compiler installed locally on your machine, and you can work from your own machine rather than having to log in to the school computers. If you're a computer science major, or computer engineering. Or if you want to be a software developer or do programming in the future after this class, regardless of your major, and a lot of people are going to get involved in that, whatever your major is, that you might want to invest the time to learn about how to code on your local machine. So that would avoid that problem. That means installing Visual Studio if you're on Windows or one of the free alternatives, although Visual Studio is free for students. And once again, I can help you individually with kind of figuring out how you might want to set up a local development environment. So that's one way to kind of ensure access to the tools you need to do the work in the class. But yeah, that's a valid complaint, and I accept that. And if someone is submitting late because they couldn't log into the lab machines, then please let me know. And I'll grant you an extension to submit late. All right. All right, so we're in Lab 4. I'm going to go ahead and make a directory for Lab 4. And problem 3 specifically. Some of you have trouble, you lose connection, when you're logged in remotely, and then you go back in and you've lost some of your work. Well, one way to avoid that is to use Screen. It's a Screen utility that's on the system. And it gives you basically these a set of virtual screens, and you can play with this like this is I am screen 1, right? And if I do Control A, C, then I'm screen 2. And if I do Control A spacebar, I can toggle between the screens. Control A, C, this is screen 3. Now I've got 3 screens. And it's a nice little tool, you know, it's for if you do a lot of work on the command line. Now if we get disconnected, then I can resume. It'll look something like this. I can cleanly disconnect. And now, you know, Control spacebar, I'm outside, but my screen session is running in the background. I'm just not connected to it through my terminal window. And then I can resume it. There it is. See, I'm back in my screen session. So if you get disconnected, then your screen session remains running in the background, and you can simply resume into it. You need to read about the screen utility and just, you know, to figure out how it works. So that's something that you could do. All right, let's go into this lab for exercise 3. And I have 2 screens open here. There it is. And I'm going to copy from lab lab 3, I think. Do I have anything? Yeah. Just going to copy some starter code. Just going to set up my development environment. I always try to get a build as early as possible. And then my strategy is to do incremental implementation. And you get as many, you know, intermediate builds and tests as possible. Should say OK. There we go. All right, so we got our basic program set up and building and running. Now let's go to the problem. So write a console program. All our programs in this class are console programs. They run in the console or the terminal window. That asks the user to enter a positive integer. The program, oh, you know what? I'm going to do, because my memory is not very good, I'm just going to go ahead and do that without reading the rest of the problem. You see, by taking care of a little task and getting it out of the way, I can simplify the problem. I don't have to remember, you know, if I just code it up, get it done. That's one of the reasons to do incremental development. Break the task down into a sequence of steps. So an integer, I'm going to call it n, and let's read it in. Maybe I'll prompt the user. And I don't want a line break there. I'll just do it on the same line. There we go. And look, incremental development. I'm just going to go right ahead and make sure I don't have any errors at that point. Okay, so we've, in a sense, simplified the problem by getting a small necessary job done right away and setting that aside. That's a job that's done. The program computes the prime factors of the number and prints them. The program computes the prime factors of the number and prints them. For example, if the user enters 100, the program enters 2255. That's because 2 times 2 times 5 times 5 is 100. And 2 and 5 are prime. This is called the prime factors. And develop 8 test cases and verify that your program runs correctly for them. The test cases should contain some prime numbers as well as non-prime values. Include the test cases within a multi-line comment in your program. Make sure the comment is nicely organized and easy to read and understand. And then use this name here. Okay. So I'll use this test case. I'll use 100 as the first test case. This is a multi-line comment. Multi-line comment is everything that appears in between the slash, asterisk. That's the opening token of the comment, and the closing token would be asterisk slash. Now we should have some simple cases, right? So if you enter 2, 2 should be, just give us a single prime factor 2 itself. And then 3 gives us 3, 4 should give us 2 and 2, and so on. A 9, which is a non-prime, but it's not divisible by 2. That's an important test case. And 27, I think, is also an important test case because it's a non-prime that's not divisible by 2, but it has more than 2 factors. Actually, I'm going to reorganize because I think it's easier to look at if I do this. And we need 8. So we have 6. What are some other good test cases? 2 more. How about something like 57? That's just 57, right? Is that prime? And what's another one? Say, how about 58? What's 58? It's 5, 5 is 20. That's 26. 2 times 26. 2 times 26, which is that right? 4 times 13? 26. No, I didn't do that right. 2 times 29. Huh? 2 times 29. Good, thanks. An extra 2. Good. But I like that test case. Maybe we should just do another one. Would we be able to find? Would we be able to find that? That's 20, right? And I'm going to put that in the right order. Put it up here. Let's do these tests. All right. So there could be any number of outputs. There's at least one. And but there could be 30. I mean, we could just calculate 2 times itself 30 times, use that as a test input. When you don't have a known sort of number of things that get produced or that get processed, then you need a loop. So we're going to have some kind of a loop. And in my mind, I'll tell you right now, I don't know the answer. I don't know the answer. I'm not typing this up from memory. I'm not typing this up from memory. I didn't memorize the answer. I used this maybe a half a year ago in a class I taught. And I vaguely remember how I did the solution. So it's not completely truthful that I don't know the answer. But Right now, I just don't know, but at least I know I got to have a loop. Because it's an unknown number of outputs. So there has to be some repetition. So I'll make it an infinite loop for now. And there'll be some condition in here. If, some condition, and what I'll do there is, and this is just, I'm roughing this out. Some condition, maybe if the condition is true, then I'm going to break. And what break does is it says, exit the loop that you're in, the immediate loop. You could have a loop within a loop, just exit the inner loop. So break means to exit the loop that you're in. It could be a for loop or a while loop. So I know there's going to be some condition that if I'm going to use true here, then I have an infinite repetition of statements. So I'll need a way to escape, otherwise we'll go forever. So this, just we know roughly we need to have some sort of a test. And also we're going to have a prime factor. I'm going to call it say f. It's going to be some f. And we're going to have a candidate prime factor. Let's start with 2. And then we'll do something like this. If f, I'm sorry, n is the number, right? So if n mod f is 0, then f is a prime factor. Right there. Once again, we're just kind of roughing it out. So we need to generate candidate prime factor. That's the way I'm thinking. That's what I'm going to do. I'm going to say I'm going to try 2, then I'll try 3, and then I'll try 5. But I'm going to be lazy. I'm just going to try 4 because if we didn't hit it with 2, then 4 won't work. So if I try 2 and 2 doesn't divide into n, then I can safely try 4, 6, 8, 16. Those definitely will not divide into n. So rather than having a test for primeness, I'm just going to start at 2 and unnecessarily test non-prime numbers as well. I can safely do that. I'll show you what I mean. So we start with we'll start with f as 2, and f needs to be strictly less than or equal to n, and then we're going to I'm just going to increment f all the time. So that's the candidate. That's the candidate prime factor f. So once we have a candidate, we need to check to see if it divides into n. If it does, we output the number. And then we want to know, now the thing is this, what we'll do is we need to take n out. This is F. Let me think how to do that. Let's take out F from N. So let's suppose we have 9. Okay, so 2 doesn't divide into 9. So we continue the loop, and then we increment F to 3. And 9 mod 3 is 0. So we're going to print the 3. And then the 9, we take the 3 out by dividing 9 by 3. That gives us a remainder of 3. That's our new N. And then we want to break here. We don't want to keep incrementing F. We found our F. And we want to see if we're done. If N is 1, then we're done. If N is not 1, in the case that we're thinking, if N were to become 3, because we factored out a 3, then we don't break, and we just continue with the while loop, and we reset F to 2. And we take 3 divided by 2. That doesn't work. We do 3 divided by 3. Oh yeah, 3 divided by 3 is in fact 0. We print the 3. Take 3 out of N, that gives us 1. Now N becomes 1. We break from the loop. Find that N is now 1, and we're done. That's it right there. Now maybe that's hard to follow, right? The way I did this. And I could rework this code maybe to make it more elegant. But this is how I derived it. This is how, in my thinking, the way I think, and you could approach the problem differently. You don't have to follow the same kind of reasoning, but you got to do some kind of reasoning. You have to figure it out step by step. Let's see if I got it right. Maybe it doesn't work. You know, like a math proof, a math proof is a very subjective thing. You present your math proof to another mathematician, and they say, you know, I think your proof is valid, or I think your proof is not valid. It's based on human subjectivity. But when it comes to computing, you've got an objective way to decide whether you got it or not. Well, you know, as long as your test cases are sufficient, you'll know yes or no whether you have a solution to the problem. Our test case is 2 should give a 2. Well, I'm getting rid of that, okay. Two should give a 2. 3 should give a 3. Whoops. 4 should give a 2. And let's just keep going. 5 should give a 5. 6 should give 2, 3. 9, that's one of our test cases, 3, 3. 27 is a test case, that's 3, 3, 3. Was it 57? 319, I got it. And the other one was it 58? 229. Did I get that right? 319. Wait a minute. What did it say? 57. Is 57 3 times 19? Look at that. Our test cases were wrong. That's another problem with developing test cases. You know, there's a software development strategy called test first, and you create your test cases first. In fact, you write code to automate testing, and then you develop code against your pre-written tests. That's called test first. It's great. You know, it's a very popular technique. The problem is, what happens if your test code is faulty, and you're writing against faulty test code? So then you got to write tests for your test code. Well, It's kind of recursive at that point. So I guess the story, the moral there is there's no silver bullet to getting your programs to be correct. 58 is 229. Let's try 100. That's the last test. There it is. Once again, I think you can come up, I think you should work this out on your own and think about the ideas and the concepts. This is for you to practice problem solving with. Okay, that's that. What's that? 58? Yeah, we did 58, 229. Let's add the lab. I'm going to do this in a way that I don't want you to do it. Oh, I accidentally added a dot out. All right, let's take it out. A lot of students are asking me how to do this. So I can do SVN remove or RM. I think that's shorter. I'm not even sure that remove works, but I think it does work. A dot out. Error. If you read the error, it says use --4 to override this restriction. Local modifications may be lost. If we did a commit and then we did the remove, then we wouldn't get this error. So it's telling us what to do. See, it's saying a dot out has local modifications. Commit or revert them first. I don't want to revert. I'm not going to talk about that. So I'm just going to force it. Oops, no space here. There it is. Now nothing has been sent to the repository. This is just local, or manipulating what's called the local working copy. We can look at, if we just do status, it shows us that, oh, there's a file in lab 3 that we don't know what to do with. Actually, I haven't committed this lab 3 folder, so I can work on that. Let me clean this up, and that's 2, right? A dot out. So it's not in the repository. I don't have to delete through Subversion because there's no record of it being in the repository. That's what the question marks are. So I can safely remove that. And I'll add the A1 folder. Oh, it's already in the repository. A1 is already under version control. And let me just get these answers. I think they might already be in there as well. All right, so it doesn't know what to do with answers to and main.cpp. All right, let's see. And I don't want to spend too much time on this. All right, we did a commit. It still doesn't know what's going on with that, so I'm just going to go ahead and put those in there. And I don't need main in there. I think there's an ignore, is there an ignore command, svn ignore a1 dot slash rather main. Yeah, I don't remember how to, from the command, I usually use a GUI when I do work with Subversion. I don't know how to set the ignore attribute for that file. So I'm just going to ignore it myself for now. Okay, that's in there. All right, let's look at problem 4. That took a while. Also 3. I made a copy, and this is now problem 4. I'm going to set up for the development here. So I've got my starter code, and it's not going to be this stuff. It'll be something else. Right? Let's see what the problem asks for. Generating random numbers or random colors. Write a program that generates a different list of 100 random RGB color values using hexadecimal notation. The program should write something like the following into Cout. So this is a number, and that number is in hexadecimal notation, right? So decimal notation means digits are 0 to 9. In hexadecimal notation, digits go from 0 to F, right? 0 through 9, followed by A, then B, then C, then D, then E, then F. And F is, as a digit, is essentially 15 in decimal notation. So you can represent numbers using different bases. So this is hexadecimal notation is referred to as base 16. The normal numbers that we work in is in base 10. We represent numbers using base 10. So each position in the number is a multiple of a power of 10. That's a decimal notation. But in hexadecimal notation, each position in the number is some multiple of a power of 16. So just to keep that in mind. And you'll see this if you develop, say, like web pages, or if you work in Photoshop or other kind of image editing tool. I'm sure that you're used to looking at hexadecimal numbers. That's what these are. So once again, this is just a number. And this part of the number here is the red component. And this part of the number is the green component, the middle two. And the final two is the blue component. So your task here is to write a program that generates 100 randomly generated red, green, blue values in hexadecimal notation. These are the digits that are used to represent hexadecimal numbers. So we can essentially, there's many different ways of generating this random number, but we can just randomly select 6 entries from this array, or from this set. So each RGB value is 6 characters long. So we want to randomly select one of the following 16 characters, 0 through F. And this is just to get started here. So this is, what we need, well, let me talk about that in a minute. Let me go back to, I don't want to read all the words out here. I just want to explain in words what we're doing. So just concentrate on the output. This is a random RGB value, a random RGB string. This is another, and we need 100 random RGB strings. How are you going to start this problem? Think about it. Isn't this hard? How do you get started? What am I going to do? How many people have an idea? Oh, I know what to do next. I know exactly what to do next. How many people have that feeling? Well, I see one. You don't have to raise your hand that high. But I want to tell you that it's a mystery, isn't it? I mean, how do you solve these kind of problems? And I don't know how you think, but I cannot get the whole concept of the solution in my head at one time. I can't do it. I got to break this down. I have to think about, well, let me work to the end result. Let me think about what can I do next that's going to take me in the direction of getting a solution complete for this problem. I need to print 100 strings that are 6 characters long. Let's do that. Let's print 100 strings that are all zeros. That's what I'll do next. We got to do something 100 times. That means we have a for loop that runs 100 times. There's a for loop that runs 100 times. We got to print some random string. I'm going to call it RGB. And RGB is going to be a string. I'm just going to create, this is, you could call this a stub. Well, not exactly, sort of. It's a step. It's not a complete solution, but it does something that's sort of approximately what we want in the end. We're going to generate a string, and I'm using a variable called RGB, and we're just going to set it to all zeros for now, and then we're going to print the string. We're going to do that 100 times. Okay, there it is. That's as far as I want to go right now. All right, I'm sure that's 100 values. In fact, it's too many to look at. I'm going to set it down to 10 so I can see it on one screen. And then when I submit my work, I'm going to change that number to 100. But it's just if you can do it twice, you can do it 100 times. It's just a matter of setting the loop. There it is. Okay. Now that doesn't fill my screen up so much, and I can get a better handle on it. All right, well, these digits need to be random. Oh, so I think what I'm going to do there is I'm going to have, oh, I got the idea. This just came to my mind. What I need to do, I have to do something 6 times. I need to generate 6 digits. I have to generate a digit 6 times. I have to repeat a process 6 times. Well, let me do this. I need to repeat a process 6 times. There's my process. There's my loop. it lets me do something 6 times. And I'm going to start with an empty string, and I'm going to append a digit 6 times. Let's suppose my digit is 1. I'm going to append 1 onto the string 6 times. That's an operation for appending a character onto a string. I think that works. I need to test it. Looks good. Now, all we need to do, well, not all we need to do, I'm going to go one more step. I'm going to say this is a random value. I'm going to call the random value the random digit, maybe D for digit. So I need to generate a random digit. I'm just going to call it 2. It'll be some number, right? I don't think that works. We're taking a string and we're adding. We can't. This is an invalid operation. We can't just. This is a different data type. You know, if this was a string, then I could do that. Let's see. This will be a compilation error. Let me just show that to you. It is not a compilation error. I can believe it. What does it do? It doesn't give us what we want. We're trying to append a 2. Actually, it's appending ASCII. I think it's appending a character whose internal representation is a 2. Anybody know the ASCII code for a letter? Any letter? I'm going to try 77. I didn't know the language did this. It's uppercase M. Like N should be 78. There it is. I didn't know it did that, but now we know. It sort of opens up a new possible way to solve the problem, but I'm not going to go down that direction. Instead, I'm going to do it like this. I'm not going to go in that direction. I'm going to say, if I want a 7, if I want let's say a 7, I'm just going to generate a string which has a 7 in it. And then I'll append that short string onto this string accumulator RGB. All right, there we go. Now, what we need to do here is to generate this, a random string, 0, 1, 2, 3, all the way up through 9, and then A, then B, and so on. So there's 16 possible values. Let's generate a random number. And then let's divide by 16 and take the remainder. So R is 0 through 15. That gives us 16 random, that gives us 16 different values. And then we can have a big if-else condition here. If R is 0, and there are many ways to solve this problem, I'm showing you only one way. It's not necessarily the best way, but it uses the tools that have been covered so far in the class. So if R is 0, let's append a 0. Else, if R is 1, then let's append a 1. And let's keep going. Whoops. That's a 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Maybe I went one too far. All right, so let's, when R is a 1, we append a 1. When R is a 2, we append a 2. When R is a 3, we append a 3. This is kind of a brute force way to do it. Did I mess it up? And this is 7. Actually, we could have used that discovery about appending an int onto a string. We could have used that discovery to make this code a lot shorter. And but I'll leave that as an exercise, or maybe we'll do that in lab. So if R is a 10, then we want to append an A. That's the hexadecimal digit for a 10. If R is 11, we want to append a B. B is 11. If R is 12, we'll append a C. And if R is 13, we'll append a D. If R is 14, we'll append an E. R is 15, we'll append an F. And we don't need that. We don't need that. That's it, right there. We generate a random value between 0 and 15, and then we enter this if-else statement and append a corresponding digit onto the string accumulator. There it is. Look at that. Well, there's still one problem to solve. Every time I run the program, I get exactly the same sequence of numbers. See? 76931F, 76931. It's the same sequence of random numbers. That's because we're using a pseudo-random number generator that takes a seed. We need to pass in a new seed value. And that's given on the web page. I would call sran. This sets the seed for the random number generator. I'm going to set it to the number of seconds that have elapsed since some epoch. That's time 0. And we need a header to bring in that time function. All right, there it is, EB0D54. FF73, so we have a different sequence of random numbers that we're picking from now. I don't think I had, did I ask for test cases?
I don't think so.
So I don't want this in there as a comment in that case, so it should have a clean program. That's it. Any questions about this one? This is due tonight. All 4 problems are due tonight at midnight. All right, I'll see you later.
up.